Good morning, dear students. We'll see now question number 2 of exercise 1.1, how to solve this one. In this question you are given, question number 2, you are given that R is a relation on set of real number. In that question it is given set of real number. In that question it is written R and real number relation is also written as R and real number is also written as R. So to differentiate it, I have written this is real number, this represents real number and this is our relation. So defined by, this is the relation, A is related to B. A is related to B if A is less than or equal to B square is the meaning of this. That means what? A and B are real number, A and B are real number and A and B will be related if this one. So A and B are real numbers. So real numbers means you should not think about only integers. Any other number also you will have to, you can think, means any fraction also you can think about integers and fractions, whatever it is. Okay, so now you are asked to show that this is not reflexive, this is not symmetric, this is not transitive. So whenever you are asked to find out, so that it is not whenever you are asked to nullify that it is reflexive, symmetric or transitive, then it is enough to give an example. If you are asked to prove that it is reflexive, then logical proof is required. But if you are asked to show that it is not a reflexive relation, one example you cite. Okay, now we are going to show one example to show that it is not a reflexive relation. So if you take say 1 1, if you take 1 1, then 1 see this relation. A in place of A is 1, in place of B there is 1. So it will be what? 1 is less than 1 square. It is true. So 1 is related to the 1. 1 is related to 1. Or if you take 2, means integer you take, then take 2, then is less than 2 square is 4. This is also true. That means 2 is related to 2. In that way all integers will be related to themselves. So, but we need to show that it is not a reflexive relation. So integer will not work. Integer will not work. You can take negative number also. Say -2 and -2. Whether they are related, let us see. So -2 is less than -2 whole square. So this is also true. It is 4. 4 is greater than or equal to -2. So that means all negative integers also will show that it is reflexive. So we'll have to go for one rational number. So let us think about 1 by 3 and 1 by 3 or 1 by 2 or 1 by 2. Okay. Now think whether 1 by 3 is related to 1 by 3. Let us see. Okay, so for that 1 by 3 you write in place of A, 1 by 3 is less than 1 by 3 whole square. 1 by 3 whole square means what? 9, 1 by 9. Now tell me, is it true? No. 1 by 9 is not greater than 1 by 3. 1 by 3 is greater. Actually, it would have been 1 by 3 is always greater than 1 by 9. It is not true. It is not true. That means what? It is not true means this is not true. 1 by 3 is not related to 1 by 3. That means what? We can tell now this is not reflexive because 1 by 3 is not related to R. So this is 1 by 3. You can take 1 by 2 also. So this example we will write this is not reflexive because 1 by 3 and 1 by 3 doesn't belong to R. That much is enough. Now come to symmetric relation. Take 1 3. Whether 1 is related to 3 or not? 1 is related to 3. Is it correct? Let us see here. In place of A you write 1. In place of 3 you write 3 square. This is what? 9. 9 is greater than or equal to 1. It is true. That means this is true. Okay. That means what? This is true. Now, if it is symmetric, we must have 3 is related to 1. We must have this one. So 3 is related to 1 or not. Let us see. Right here in place of A, you write here 3. In place of b, you write here 1 square. Is it true? No, it is not true because 1 is not greater than 3. That means 3 is not related to 1. That means what? 1 3 is related to 1 is related to 3, but 3 is not related to 1. Or you can write 1 3 belongs to R, but 3 1 doesn't belongs to R. That is why it is not symmetric. Okay, fine. Now the last one, transitive. We'll have to find out an example which show that it is not transitive. Okay. So now let us take one example where 3, take one positive number and one negative number. So now see whether 3 minus 2 square is 4. 4 is greater than or equal to 3. It is true. This is true. That means this is true. Okay. So, and using minus 2 is related to minus 1. Let us see whether minus 2 is related to minus 1 or not. Minus 2 is related to minus 1 or not. So, minus, in place of a you write minus 2. In place of a you write minus 2 is less than or equal to minus 1 square. That means what? This is minus 2 is less than 1. Minus 2 is less than definitely 1. That means this is true. So this is also true. This order pair ending with 2. This is starting with 2. So we must have, to get transitivity, we must have 3 is related to minus 1. Let us see whether 3 is related to minus 1 or not. So you write here in place of a, you write here 3, and in place of minus 1, you write here is greater than minus 1 whole square. This is 1. So 1 is greater than 3. No, this is wrong statement. That means this is wrong. 3 is not related to minus 1. What we have got now? 3 is related to minus 2. Minus 2 is related to minus 1. But 3 is not related to minus 1. So it is not transitive. So in this way, citing example, we can show that it is not symmetric, not reflexive, and not transitive. Hope you have understood. Thank you.